Today's notes are on parallel lines and transversals. So what we're going to do today is we're going to apply the properties that we learned yesterday of angle pairs. So your corresponding angles, alternate interior, alternate exterior, same side interior and exterior. But see what happens when we have parallel lines. Okay, and then we're actually going to construct a parallel line. So as a quick reminder of yesterday, what we did is we talked about when we had two lines with a transversal, we were able to pick out corresponding angles. So you move along the transversal and you have to say like angle 1 and angle 3 are in the same spot on that image. So angle 1 and angle 3 are corresponding angles. Angle 2 and angle 4 are corresponding as well. 8 and 5, and lastly 7 and 6. All are corresponding angles, meaning they are sitting in the same spot as the other one in the angle pair. Alternate interior angles, remember, are on the inside of the two angles that are crossed over by the transversal. So alternate interior angles, you would take one, let's say 3, and then you would go across that transversal, so get 3 and 5. 7 and 2 are also another pair of alternate interior angles. Alternate exterior are on the outside, so 4 and 6, and then 1 and 8. Same side interior, so we're going back to the inside again, and you have to stay on one side of that transversal. You cannot cross over it, so 7 and 5, and then 3 and 2. So that's what we did yesterday. So today we're going to look now and see that your two lines that are being crossed over by the transversal are parallel. And so what happens is that every single angle that is formed by that transversal, they're going to be supplementary or congruent. And how we figure that out is we play a little quick game of tic-tac-toe. We're going to alternate X and O, starting with the same spot, so therefore your corresponding angles would have the same letter in there. And what I'm going to tell you is all of your X values are the same, so they are congruent. So this angle is the same value as this one, which is the same value as this angle and this one. So this kind of helps you organize your thoughts, which just also means that all of your O's are congruent as well. But what happens if you're looking at two angles and one is an X and one is an O? Well, any X plus O is equal to 180, which makes it supplementary. So what this means, it says if two parallel lines are cut by a transversal, then you can say corresponding angles are congruent. So if we do our X and O's here, corresponding angles, let's say 1 and 5. Well, look at angle 1 and look at angle 5. They both have that X. So that means that X's are the same measure, therefore they are congruent or equal. We can also talk about alternate interior angles. Okay, alternate interior angles are, let's say, 3 and 6. Now, 3 and 6 both have O's. So guess what? Those are also congruent as well. If we talk about alternate exterior angles, then we look at, let's say, 1 and 8. Now, those are both X's, so if we want to say we have alternate exterior angles, then we can say that they are congruent. And then the last one would be same side, interior, and exterior. They're the same thing. And those are, let's see, same side, interior would be 3 and 5. Look at, you have 1 X and 1 O, and then exterior would be 2 and 8. Again, 1 X and 1 O, and because they are different, that means they are supplementary. So you would add them together. Angle 3 plus angle 5 equals 180. So that's how you would do those. So here's a couple examples. Using the statements that we just came up with, we're going to come up with a conclusion. We're going to say that, are they supplementary or are they going to be congruent? So for angle 1 and angle 2, if we play our game of tic-tac-toe, we're only going to look here. And those two angles are x's, so we can say that angle 1 is congruent to angle 2 because they're both x's, which means they are the same or equal. And the reason behind this is if you have two parallel lines, then we know that corresponding angles are congruent. On the inside here, you've got angle 1 and angle 2. So we're just going to look here. You have one x and one o. So we can say that angle 1 plus angle 2 is going to equal 180. And we know this again because if we have two parallel lines, then same side interior angles are supplementary. And the last one, here we have XO, XO. We're looking at angle 1, which is an x, and angle 2, which is an x. So because they are the same letter, again, we're going to say angle 1 is congruent to angle 2. And we know that because if we have two parallel lines, then alternate exterior angles are congruent. And you're probably thinking, well, how are you getting corresponding? Same side interior, alternate exterior. Well, it's just based on where that angle is located within your image. So corresponding 1 and 2 are sitting in the same spot. Here they're on the same side, but inside those parallel lines. And here they're alternating, but on the outside of the parallel lines. So that's why alternate exterior. Let's take a look at some images with numbers. So here it says find all the measures of all the angles. Well, in example 1, I only give you one angle, and that's 65 degrees. So how are you supposed to find the 7 other? If you said tic-tac-toe, then you're right. Let's go ahead, draw our tic-tac-toe board. And remember we talked about every x value is the same. So that means that angle 1 has to be 65 degrees, and you can also see that they are vertical angles, and these are congruent as well. Angle 4 and 7 are all 65 degrees. So angle 1, angle 4, and angle 7. How do you find the measure of all the O's? Well, if you take a look at any of these, let's say the two same side interior, here you have an X and an O, and we know that those are supplementary, so they would add up to 180. Therefore, you would do 180 minus 65 to get your O, and it's 115 degrees. So any O measure is 115 degrees. And that's how you do that problem. In example 2, you have two sets of parallel lines. Therefore, at some point, one of these lines is going to be a transversal. So we're going to do this XO because they are all parallel. We are allowed to do that. And here, I only give you one value of 100. And it's an O. So here we've got angle 3 is an O, angle 1 is an O, and angle 6 is an O. So all of those measure to 100 degrees. And again, to find the x value, you would subtract from 180, and so therefore all the rest of these are 80 degrees. In these, here we are actually going to have to solve for an x value. So in order to figure out which option you're going to use, and the first option is to set equal, and the second option is to add to 180. And how we know that is if we have both x's, you set them equal. If you have both o's, you set them equal. And if you have one of each, you add them. So that may be something to remember right there. So as we continue our tic-tac-toe board, notice that you have one O and one X. So what do we do now? We're going to add them together. So you have 125 plus X plus 15 and set it equal to 180. Here you have X plus 140. When you subtract, you have X equals 40. And that's your answer. In problem number 4, if we do our tic-tac-toe board again, notice that you have an X and an O, and guess what we do again? Set it equal to 180, so 110 plus 4X plus 10 is equal to 180. So 4x plus 120 is equal to 180. When you subtract 120, you're going to get 60, so x is 15. And the reason behind that is same side interior angles are supplementary. In example 5, if we go ahead and do our XOs, our tic-tac-toe board as I like to call it, we look to see what we have. Here we have an O and an O. And if you look back on that little cheater I said, here we have two O's and they're equal to each other. So that means that we're going to take each of these and set them equal. 90 minus x and x. And then when we solve, we're going to add x to both sides. Here we have 90 equals 2x. Divide by 2, so x is 45. And the reasoning behind this is alternate exterior angles are congruent. One more, if you take a look at these two angles, they really have no relation. They're not corresponding, they're not alternate interior, they're not alternate exterior, so how are we going to do this? Well, if you notice that x and x are the same, they're also vertical angles, so that angle measures 94 degrees as well. So we can look at it this way. Here you have 94 degrees for x, 13x minus 5 for O, and again, if you look back at the little cheater we came up with, we add them together and equal it to 180. So here we have 13x plus 89, which would give us 13x equals 91, and that gives us an answer of 7. So if you have your compass and protractor, we're now going to construct a parallel line to AB. We're going to construct CD. So the first thing you have to do is you're going to take your protractor and you're going to draw a straight line through C and through that given line. That is your transversal. What I want you to do is I want you to put your pointer right here on the intersection of the transversal and the line AB. If you stretch out your compass, I'd say to about here, what you're going to do now is you're going to create an arc. Ooh. Mine's a little off because I don't have a compass feature for my computer. Okay, so keep that same distance and pick up your pointer and you're going to move it to this point C. And I want you to do that same arc again. What you do now is you're going to put your pointer right here on the intersection of your arc and your transversal and measure all the way to the other point of that intersection arc. Pick up your compass, put your pointer right here at the transversal intersection and the arc, and I want you to draw a little arc here. That is your second point in order to draw, that's your point D, in order to draw a line that's parallel. Mine don't look very parallel, but again, I don't have a compass feature for my computer. But that's the basic step. If you have any questions, please let me know. Otherwise, have a great day.